Okay, in the last session, we discussed arithmetic operators. Simply addition, subtraction, multiplication. There is no difference. All are mathematical operations. The only important thing is among this one and this one. So the main thing is here, if both the numbers are also integer numbers, the remainder is the float. That is, the quotient is float. The example we discussed is 5 by 2. So it performs exact multiplication. If you are division, that is a slash symbol, it performs exact multiplication. But coming to this double slash, this is called floor division. What is mean by floor operation? Floor is an integer number. That is simply it removes the point. So 5 double slash 2, the answer is 2 only. It removes this one. For example, in this case, 5.3, suppose double slash 2. In this case, the answer is 2.0 only. Even though if at least one number is the floating number, the answer is also in floating, but always it is 0.0. Whatever the number, whatever the divisible factors you have, always 0.0. And the modulus operation is used for getting the remainder. So if you want to get the remainder, generally we are performing double slash. Suppose if you are performing single slash, always the remainder is 0. Why? Because we multiply with the floating point numbers. Suppose for this case 5 into 2, 2 2s are 4 and the remainder is 1. And double star in the sense power operation. This is completed with execution. These are the relational operators. The result of relational operator is true or false. True or false. And then logical operator, three expressions, logical and logical or logical not. So end means if both are true. If both are true, then only it is true. Or means if at least one is true, the result is true. Not means if given is true, the result is false. If it is false, that is true. That is simply conversion. Now we are right now at bitwise operators. Actually, we completed bitwise and bitwise R and bitwise XR. Again, I will repeat. Bitwise operator, the name specifies it will perform the operation bit by bit. We can apply these operations bit by bit, and it is applied only for integer and boolean. Only for integer, that is for floating point numbers, it is not possible to apply bitwise. Why? Bit by bit, bit by bit. Suppose if you are trying to apply for any other type, then it will get error. We will get an error. For example, end operation, or operation, the meaning is same. If both are true, the result is true. Or operation is if at least one is true, the result is true. For example, A is equal to some 6, B is equal to some 7. These are the two numbers. Now you have to perform A ampersand B, that is end operation between A and B, or operation between A and B, XOR operation between A and B. First, to convert 6. What is the binary representation for 6? This is the binary representation of 6. B 1 1 1. This is the binary representation for 7. Now perform A and B, 0 and 1, 0, 1 and 1, 1, 1 and 1, 1. So now convert it to decimal. The decimal value is 6. So by performing A and B, the value is equal to 6. Now A or B. So 0, 1. If at least 1 is true, the result is true. 0, 1, 1, 1 and 1, 1, 1 and 1, 1. The answer is 7. The answer is 7. Now, you remember XOR operation. In XOR operation, if both the bits are same, the result is 0. If bits are different, the result is 1. 0, 1. The answer is 1. If 0 and 1, both the bits are different, the answer is 1. 1, 1, both the bits are same, 0. Whether it is both are 0 or both are 1s. If both the bits are same, the answer is 0. 1, 1, 0. Now, what is the decimal value? The decimal value is 1. These are the three operators. Now, coming to Complement. Complement in the sense converting, one second. Complement in the sense converting ones into zeros, zeros into ones. That is called complement operation. And left shift, right shift. I will explain all these concepts. For example, A is equal to 5. The tilde symbol, this is called tilde symbol. Tilde A is equal to what is the value? First to 5 is converted into binary. This is the binary representation 5. Remember, actually, this is not the correct binary representation. For example, assume an integer occupies 16 bits. An integer size of integer is 2 bytes, not 3 bits. Remember, for every integer or every floating, every double, there is some fixed size. This much amount of memory is allocated. For simplicity only, I am writing 101. Assume an integer occupies 2 bytes of memory. An integer occupies 2 bytes of memory. 1 byte is equal to 8 bits. 1 byte is equal to 8 bits. 2 byte is equal to 16 bits. That means your integer number is stored in 16 bits. Integer number is stored in 16 bits. Remember, this is not fixed. Depending upon the architecture, it may be 4 bytes or say 8 bytes or 10 bytes, whatever it is. Assume if an integer occupies 2 bytes, then what is that? Total 16 bits of memory is allocated. This is fixed. Total, if it is 2 bytes, total 16 bits is allocated. Now I am using 101. Now the remaining 13 bits are 000. If left side we have writing 0, if there is no use, that is the reason I am not returning anything. You got my point? Why I am writing 101? For example, number A is equal to 8. I am representing by using 4 digits. Why? Simply for representing a number, we are using the last one position. Before that one, anything is 0. So writing zeros is not at all useful. That is the reason I am representing. So, and especially among these 16 bits, only 15 bits are used to store the value. 15 bits are used to store the value. The last bit, that is the 16th bit, is to store the sign of the number. Sign in the sense it is a positive number or negative number. So if 0 is equal to plus, that is the positive number, 1 is equal to minus. By default, we have zeros. So A is equal to 5. 5 is a positive number, that is we are writing 0. Suppose what is mean by complement? The complement in the sense 1, 1, 1, 1, 1, and so on. This one is converted into 0, 0 is converted into 1, 1 is converted into 0. Complement in the sense converting ones into zeros and zeros into ones. That is called complement. At the time of conversion, what happens? The symbol, that is the last digit, represents the sign. Actually, here the sign is positive. After conversion, it becomes the negative number. After conversion, it becomes the negative number. Okay, and calculating, converting all these values again, converting into decimal is very time taken process. That is the reason we are using simple formula for complementing. Complement of A is equal to, the formula is minus of A plus 1. This is the formula. Suppose complement of 5 is equal to minus of 5 plus 1. That is minus 6. Observe, my given number is a positive number. Compulsory the output is the negative number. Why? After complement, the positive is converted into negative. Suppose complement of minus 4. That is minus 4 plus 1, that is minus of minus 3. Minus of minus 3 is 3. So this is the complement operation. Okay, now I will execute this complement. A is equal to 5. Now complement A. What is the value? 6 minus 6. Whatever we are getting the same thing. Suppose A is equal to minus 6. A is equal to minus 6. Complement A in the sense the value is 5. So minus of minus 6 plus 1 is minus of minus 6 plus 1, that is positive to negative and negative to positive. Now the remaining two operators, left shift and right shift. These are also some important operators. A is equal to A is equal to some 5. Left shift is symbol double less than. Double less than is represent left shift. The syntax is the variable, suppose a n. What is the meaning of this one? On the variable a, we are performing left shift operation by n number of times. Perform left shift operation by n number of times. For example, a left shift 4. A left shift 4. A is left shifted by 4 times. Left shift in the sense moving the bits to the left side. Moving the bits to the left side. Originally, what is my number? A is equal to 5. Convert into binary. 0, 0, 0, 0, 0, 0, 1, 0, 1. Right? So assume the total memory we are allocating is 2 bytes. This is depending upon the architecture, it may change. Assume now the total memory is 2 bytes. So this is total 16 bits of memory. Total 16 bits of memory. It is stored internally like this. By what is the value? The value is equal to 5. First to 4 times in a sense, first to perform first to left shift operation. By performing left shift, the bits move to the left side. So this one moves to this position. That is here it is 1. This 0 move to left side. This one moves to left side. Here at 0 position we have an empty. Any empty position is filled with 0. So actually 13 zeros. Right now we have total 12 zeros. Now, what is the decimal value? So, we will represent decimal. Again, perform one more shift. This is only one shift. Suppose if you are performing second shift, move to left side 1. This is 0. This is 1. This is 0. And this position is empty, filled with 0. Perform third shift operation 1, 0, 1, 0, 0, 0. Next shift. 1 0 1 0 0 0 0. Simple logic. 1 0 1 for first shift operation placing 1 0. For second shift operation another 0. Third shift another 0. Fourth shift another 0. So if my number is simply if my number is 1 0 1, by performing 5 left shift operations, what is the value? 5 left shifts. 1 2 3 4 5. Simple logic. For each shift operation, we are placing 1 0 at right side. We are placing 1 0 at right side. Now convert into decimal. 1 0 1. The decimal value is 10. 1 0 1 0 0. The decimal value is 20. So here the decimal value is 40. Here the decimal value is 80. Now you got it? 5, 10, 20, 40, 80. That is what is the meaning of this one? For each left shift operation, the value becomes double. The value becomes double. Why the value becomes double? Actually, in binary representation, what is this position? This position is 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, and so on, 2 power 15. So we started to 2 power 0, ends at 2 power 15, right? Now, after left shifting, what happens? The 2 square position is moved to 2 cube, right? 2 square position is moved to 2 cube. 2 power 1 moves to 2 square. 2 power 0 moves to 2 power 1. And we are adding one more chip. Suppose in the next shift, 2 cube is moved to 2 power 4. That is, each and every time we are multiply with 2. 2 cube, 2 power 4. What is the difference? Power 2. That is, each and every time we are moving into the left side. If you are left side, in the sense the value becomes increased. The value becomes increased. How much amount it increased? Each and every time it is powers of 2. That is, the value becomes double. Instead of calculating all this, simply we have a formula a into a into 2 power n. For example, a value is equal to 5. If you want to perform left shift by 4 times, so 2 power 4. What is 2 power 4? 16. 16 into 580. We got the answer, right or wrong? This is the simple notation. So why multiply with the 2 power n? Each and every time we are moving it to the left side. We are moving it to the left side. That is the reason we multiply with 2 power n. Remember. So if this is the simple example, it is very easy. For example, if my number is some 242, left shift by 5 times. Then how do you do? 242 left shift by 2 times. So first thing is you have to convert 242 into binary and then write down 5 zeros and then convert into decimal. It is very time taken process. Instead of this one, simply you can write 242 into 2 power 5. So 242 into 32, normal mathematical multiplication. The answer is very easy. So that is the concept. This is the left shift operation. That is, left side we have an empty space. That is, left side we have zeros. That is the reason move the bits to the left side and the empty position is filled with zero. That is the reason each and every time we are multiplying. So value becomes double. Value becomes double. Now, exactly, right shift operation. Right shift operation. We are moving the bits to the right side. We are moving the bits to the right side. For example, 10101110. Assume whatever it is. This is my number. So left side we have many number of zeros. These numbers are not at all important. Why? We are moving to the right side. So this is moved to this position. This is moved to this position. This one moves to this position. This one moves to, sorry, this is 0. This one moves to this position. This is moved. And here we are filling with 0. Here we are filling with 0. And we lost this value. Suppose if you are moving one more shift, we lost this value. So what is the answer? 1, 0, 1, 0, 1. Suppose if you are performing one more shift operation, 0, 0, 1, 0, 1, like this. What happens if you are moving to the right side? Actually, in the right side, there is no place. The right side, there is no place. If there is no place, in the sense, we lost the bit. So, what is the decimal number for this one? 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6. 2 power 6 in the sense 64 plus 2 power 4 plus 16 plus 4 plus 2. So the answer is simply it is 20, 84, 86. It is 86. Now obviously here the answer is 43. Check whether it is right or wrong. See, 2 power 0, 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5. 2 power 5 in the sense 32 plus 8, 40, 40 plus 2, 42, 42 plus 1, that is 43. Now here the answer is 21. See, 16 plus 4, 20, 20 plus 1, 21. Now it is 10. Now remember, each and every right shift operation, the value becomes half. But at the time of conversion, remember half in the sense 43, half in the sense 21.5. It is not possible. Why? At the time of conversion, we are moving in the powers of 2 only. Powers of 2 only, and it is an integer type only. Bitwise operators is applicable for integers only. Applicable for integers only. So simply, instead of calculating this one, suppose if you are performing one more shift operation, the value is 1. If you are performing one more, the value is 2, not 2.5 like this. Suppose simply if my number is 86, performing right shift by 4 times, assume by 4 times, in the sense simply 2 power 4, 86 by 16, 16 5 jar, not multiplication, only floor division, 16 5 jar. So the answer is 5. 1, 2, 3, 4. Simply the answer is A by 2 power n. For each right shift operation, the value becomes half. Each right shift operation, the value becomes half. Consider the same example. A is equal to 86. Now, A right shift, sorry, A right shift 1. So the answer is becomes half. No need to calculate the main thing. Simply to calculate. The answer is for, suppose A value is 86, A right shift by 4 times. Now the answer is 5. We got the value? Yes. Suppose A is equal to some 10, A left shift by 5 times. What is the answer for first shift? Original, simply calculate like this. Original value is 10. For the first shift operation, the value becomes 20. For second shift, 40. Third shift, 40 into 2, 80. Next shift, 80 into 2, 160. Next shift, 160. Each and every time multiply with 2, 320. That is the answer. 320, this is the answer. These are called bitwise operators. These are called bitwise operators. Now, assignment operator. So simply assignment operator is equal to the symbol is equal to whatever the value that is present on the right hand side, it is assigned to left side. We write up to now we are taking multiple number of times. A is equal to 5. What is the meaning of this one? The value of 5 is assigned to A. The value of 5 is assigned to A. For example, C is equal to A plus B. In the right side, first we have performing some operation. That is, if you have an expression, the expression is evaluated. First, the expression is evaluated and the result is assigned to left side variable. The result is assigned to left side variable. This is called assignment operation. Now, what are these one? So simply to simplify the operation, for example, if my program is A is equal to A plus B. Now see this one, left side to is equal to and right side to is equal to, we have same variable. What is the meaning of this one? Here we are performing an operation between A and B. Whatever the result we got, again the result is stored in A. So here the same variable A appears both in the left side and right side. Instead of writing the same variable two times, we are using these shorthand notations. So like this, we can write like this, A plus is equal to B. So these two are same. Remember, these two are same. A is equal to A plus. Instead of writing, we are writing A plus is equal to B. So remaining are same. For example, multiplication. A is equal to A into B. This is converted A star is equal to B. Only the symbol is changed. Remaining thing is same. The left side and right side have same thing. We will do like this. If you are not remembering this one, not a problem. If you are writing this one, 100% it is valid. 100% it is valid. You can write anything. But the thing assignment operation is whatever the expression on the right hand side that is evaluated and assigned to left side variable. Actually, left side we have only a single variable. Left side we have only a single variable. Now, ternary operator. Ternary operator. I will explain the concept of ternary operator whenever decision making statement comes. Okay, that is completely depends on decision making statements. After whenever that particular point occurs, I will discuss this ternary operator. Now, identity operator. Identity. It is used to check for address comparison. For example, consider any two variables. is the two variables. This is the very important. This remember this identity operator and the next one is membership operators. These two are the very important coming to Python programming language. Address comparison. Check whether the two variables points to the same address or not. Two variables points to the same address or not. We have two identity operators. One is, it is small letter, one is, second one is not. Second one is not. For example, assume A and B are two variables. A and B are two variables. If A and B points to the same memory location, if A points to this memory location, B also points to the same memory location, then A is B. What happens? If both are points to the same memory location, is operator, it returns true or false. Remember, the identity operations, the result is true or false. If both are points to same memory location, the result is true. The result is true. Now, R1 is R2. Suppose R1 is one object, R2 is another object, it is true if both R1 and R2 are pointing to the same object. Suppose if they are pointing to the different objects, it returns false. Now, what is mean by is not? We are checking if both R1 and R2 points to the different object, then it returns true. We said that it is not. If both are points to different objects, then it is true. If points to same object, it is false. Now, the thing is, generally we assume that A is equal to, ignore this one, we assume that A is equal to 5, B is equal to A. What is the meaning of this one? Whenever we are writing this statement, some memory is allocated with the name A and the value is 5. Whenever we are writing B is equal to A, that is the B also referred the same thing. We know this one. Whenever we are writing the statement B is equal to A, B also referred like this. That is whatever the value that is present in A, whatever the value in A that is assigned to B. For example, if you are modify the value of A, it will update the B also. Suppose in the future I will modify A value into 6. The B value is also updated. Why? We are assigning the reference of A to B. We are assigning the reference of A to B. Now in this case, A is B. Check both A and B points to the same address or not. It only compares the address. To check the value, we are using double equal to. We know that one. A double equal to B. What is the meaning of this one? The value present in A is compared with VB, not addresses. It is true. Now, Python has one more advantage. What is that particular advantage? Suppose see this one. A is equal to 10. Now, some memory is allocated with the value A, some 10. Generally, in the remaining languages, if you are assigning B is equal to 10, except to Python, in the remaining languages, what happens? Some another memory is located. It is referenced by B with the same value. But the advantage of Python is already a value is existed. Suppose if you want to create a new variable with the same value, create a new variable with the same value, then Python does not allocate a new memory. Simply the existing memory is referred by that variable also. You got it? Reducing the memory usage. Reducing the memory says A is the variable which is already created with a value 10. Now, if any other variable is created with the same value, if any other variable is created with the same value, then simply what to do? The same memory location is pointed by that variable also instead of creating new variable. Suppose whenever you are changing the value, then only the new memory is allocated. Now, see this one. I will execute and you will get the idea. A is equal to 5. B is equal to A. S. Now check A. is B. Both are points to the same. If you want to know, we have an operator ID. ID is an operator to display the address of a variable in this particular system. Remember, in all the systems, the address is not same. From system to system, the address is changed. ID of A. It returns the address of A. In this particular system, see, this is ID of A. Now, ID of B. This is address of B. Now see this one. Both ID of A and ID of B same. Suppose C is equal to 5. Now what is ID of C? This is address of C. This is address of C. What happens? See this one. Here again we are using the same value 5. You got the meaning? So A value is equal to 5. C value is also 5. If you are using same value, it does not allocate new memory. Already the memory is allocated. It is stored in that variable. Otherwise, suppose I will show you. A is, suppose use some other variable. D is equal to 10. E is equal to 10. Now check ID of D, ID of E. Both are same address. Both are same address. Suppose some K is equal to 20. Sorry, I am using double equal to, that is a mistake. K is equal to 20. ID of K. See this one, it is completely different value. It is completely different value. D is E. Yes or no? D value, E value, both are same. It returns true. D is not K. So yes, address of D is not equal to address of K. It returns true. We are fixed that both are not equal. Yes, both are not equal. It is true. This is the thing. Okay. And remember, this is only applicable for limited amount of numbers. For example, A is equal to some thousand, B is equal to some thousand, A is B. The answer is false. Only some small set of numbers it is possible. If the number range is valid, for example, A is equal to some 512, B is equal to 512, A is B. The answer is false. This is also false. So up to only small, so single variables 5, 6, 10, 100. Only for example, A is equal to 256. B is equal to 256. Now check like this. A is B. It is true. It is true. A is equal to 257. B is equal to 257. A is B. It is false. I think you got it. Why am I writing 256? Up to 256 only if a variable, any number of variables with the same value, all the variables have same memory location. After the value of 256, even though same value, different memory locations are created. Even though same value, different memory locations are created. Okay, this is identity operator. Identity operator. Now move to membership operator. So the membership operator is applicable on a sequence. Sequence in the sense, consider we have different data types. In the next sessions, we are good with these data types. So what are those? String, list, tuple, set, dictionary. These are different data types. That is, all those are a sequence. All those are a sequence. Suppose I will explain this one. For example, consider a string. I think you know that one string. Your name is a string. My name is a string. Simply any group of characters is called a string. Group of characters is called a string. Suppose welcome. Welcome is a string. Now membership operator has two operators. One is in and another one is not in. check whether a substring, not only string, check whether a particular object is present in a given sequence or not. Sequence are also called as a collection. Collection or sequence means simply some set of elements or some set of characters. For example, here my thing is check whether L is present in a string or not. Actually, what to do in other languages except Python? In other languages, we have to do like this. L is compared with W. That is by writing a for loop. L is compared with W. L is compared with E. L is compared with LS. There is a match. If there is a match, okay, we return the corresponding index. But in Python, no need to compare character by character. No need to compare each and every element in the collection. Simply by using in operator like this, L in welcome. If L is present in the string, it returns true. If L is present, it returns true. Not only L, not only a single character, we can check like this LC in welcome. We are writing in quotations. If it is a string, we are writing in quotations. So LC in welcome, yes. Is LC is present or not? If it is present, it returns true. That is the membership operator. Check whether a particular substring is present in the main string. For example, L is equal to 10, 11, 12, 13. Assume this is a list. You don't know the topic of list. Assume this is a list. All these topics are our future sessions. So now the check is check whether 11 is present in the list or not. So simply 11 in L. So if 11 is present, simply the answer is true. Suppose 15 not in L. So the answer is true only. Why? We said that yes, 15 is not present. We also using the same thing. 15 is not present. The answer is yes. If 15 is present, not in using, the answer is false. This is the membership operator. Once we are going with these collections, that is with this sequence, we easily understand the membership operator, the most important operator. Now the last thing is operator precedence. What is the meaning of this one? For example, the basic mathematical simple question is 2 plus the 3 minus 5, or this is my expression 2 plus 3 into 5. First, what we are doing? So always the common question is, suppose first we are performing 2 plus 3 5, 5 into 5, 25. This is one answer. Or first we are performing 3 into 5, 15. 15 plus 2, 17. This is one answer. We have always a condition which operator we have to do. If an expression contains more than one operator, more than one operator. So first which operator has to perform? That is the precedence or priority of the operators. So if an expression contains double star, though the highest priority is given to double star. That is, for example, 2 into 3 plus 5 double star 2. Then what we have to do? First we have to perform this operation. You got it? So this is the order. These numbers are given in the descending order. So the highest priority is given to double star. After the highest priority of double star, then you are using this one. This is not addition. All these are called unary operators. What is mean by unary? Only one operand. Here 2, 5, 3 are called operands. To perform an operation, only one operand. For example, a is equal to 5 minus a is equal to, simply the answer is minus 5, plus a is equal to plus 5. You got it? So the symbols minus, unary minus, in the sense simply the value is changed. Complement in the sense it performs a complement, convert ones to zeros, zeros to ones. But unary minus in the sense simply the sign of the number is changed. So first all unary operators are performed, and then multiplication, division, modulo division, and floor division. So the division operations are performed, multiplication and division, and addition, subtraction. Again, see this one. Again, we have a problem. 2 plus 3 minus 5. Now the question is, both plus and minus are at the same priority. So now the question is, if more than one operator with the same priority is existed, then we follow associativity. Associativity in the sense we are moving from left to right or right to left. Check whether left to right or left right to left. So for example, how do you perform the operation 2 plus 3? Generally not. We are performing left to right. Generally all the operators, the associativity is from left to right. That means first to perform plus operation. In this first, which operator comes? Plus. So first to perform plus operation and then perform minus operation. So there is nothing we have to remember. If we have an expression and if you want to calculate manually, we have to remember. Then right shift followed by left shift. After that, all the bitwise operators, comparison operators, and then assignment, identity, membership, logical operators. Logical operators. Okay, these are complete operators. These are complete operators. Okay. If you have any doubt, please ask me related to complete operators. Madam, if you have any doubt.
No doubt, sir. I'm good.
Okay, by that one, okay.
Yeah.